It's a GUI, like it works on the command line. Oh, here he comes. There, it's on now. Excellent. This kind of carries on a little bit from the session this morning, which I assume most of you were in, where we were talking about FlashGrid. And Shelley, I think it was when we were in Sweden the last time, over dinner we were talking, and I was like, we do know that you can build an SVC cluster twice as big if you make it a grid. And she went, what? So she's like, right, we need to do a session all about SVC in the grid. And so the first slide is kind of the same, but it's a SVC grid as opposed to a flash system grid. Same kind of marketing message, same kind of text on there. And I spent some of my lunchtime doing some wonderful photoshopping in Keynote. And I thought that would be a good like, bit of advertising. So I'm sure I'm breaking so many rules by doing that right now, but anyway. Well, the Dell down the side, yeah, forget about it. It was like the Ferrari. How many? Someone told me there's something like 11 HP logos on it or something like that. So anyway, so similar to what we were talking about this morning, the SVC grid. So if you're wanting to build a grid out of just SVC systems, the various contenders that we have there that you could add into a grid start with the SA2. So still in market, still being sold if you want a kind of lower price point, less performant than the big SV3. So the SA2 can be added into a grid. And the previous kind of high-end node, the SV2, can also participate in a grid. This is basically anything that can be running 870 code. So when it comes to SVC, the old DH8s kind of terminated on 8.5, I think. The SV1s were similarly terminating about that point. And so you need to be on some of the later hardware in order to get up to 8.7 to be able to create the grid. And of course, obviously, the remaining one there is the SV3, so the current kind of high-end node, shares most of the hardware with the 9500 in those terms. So if we look at that in terms of why, funnily enough, I'm going to go pretty quickly through this because most of the value propositions are still the same. Now, you could say that an SVC cluster has always given you a federated management and a federated set of data. The one key difference here, obviously, is the pools themselves. So a pool in an SVC cluster is a kind of symmetric access to every node in the cluster. So a pool is common. Whatever storage you present behind an SVC cluster always has to be presented to every node in that cluster. It's one of the kind of fundamental rules. And then volumes are individually owned by I/O groups. The difference here is because these are only single I/O group systems that are then encapsulated in a grid, now your pools are more like what was happening with flash system. So it's more siloed in the sense of it's a single I/O group that's going to have its own pool with some storage presented to it. Next system in the grid, single pool with some storage presented to it. Now, we'll cover off some of the things you could do if you want to in just a moment to kind of still have a single controller presented to multiple systems in the grid. Non-disruptive workload migrations, again, we'll cover that in a bit of more detail about the differences. You're still going to get all those AI ops, storage insights, data placement recommendations as they come on board. And one of the key differences, now you can bring non-IBM storage to the grid. Technically, you could do that with a flash system as well, because you could virtualize behind the flash system, but it's an option here to, if you're wanting to get off of something and move into a flash system, this could be something that you could look at doing. So it does, however, give us that extended scalability that we talked about. So 8 systems in the grid today with the code levels, that means you can have 8 node pairs. So that's giving us 16 nodes in a grid, which is twice the scalability in terms of performance, double the number of nodes, but it's also 8 times the volumes and the snapshot. So volumes and snapshots are cluster limits. So today, 2-node SVC, 8-node SVC, same number. Now, because we've got 8 individual systems or 8 individual clusters of just 2 nodes, we get that 8 times scalability because each one of them can have that cluster limit applied to it. So it does give you, if you're creating thousands and thousands of volumes, as I know some of you do, then potentially it does give you the ability to go beyond the 16,000, 32,000 type limits that we have today. As we move into the next release, and again, we'll cover this in the roadmap, and Chris mentioned this morning, we can now, or we will then be able to have 32 systems in the grid. That's now 64 SVC nodes. So giving us 8 times the node scalability, 8 times the performance out of the whole grid, and 32 times the volume scalability. I forget what the numbers are now. Chris probably knows them off the top of his head, but it's into millions of volumes potentially that you can be creating, and snapshots as well. But 32 single IO group systems. So, bringing your non-IBM storage to the grid. I couldn't bring myself to put any orange on this chart. I drew the line there. But any of the 500 plus controllers that we support in virtualized mode, they're out there. They're not part of the grid at the moment. Maybe you've just got some flash system, a couple of flash systems. Put an SVC on top of those, virtualize it. Now you can bring those workloads into the grid. You could leave it like that. You could have it there as the storage being presented up to it. Or if you're wanting to retire those things off, you could use that as a mechanism to obviously move your partitions off of that non-IBM storage. So, why is grid better than clustering? This is the ultimate question. Why would I move? It's obviously a bit of a design change you're going to have to make. It's potentially kind of creating more work for you. Depending on how, if you've got let's just say a 4-node SVC cluster today, potentially you have applications that you've deliberately spanned across multiple IO groups, performance reasons, whatever it might be. In order to create a partition and move it, you have to have that in a single IO group. So before you can even think about doing some of these things, you're going to have to consolidate those volumes into a single IO group. However, the advantages that you get from partition migration versus just standard SVC back-end storage migration is exactly that. When we had SVC, too many screens here to know where to point. Point at this one, I can see it there. Over here, with a traditional SVC, you've got mobile media, basically. You can move things around behind the SVC. Nobody cares. Do it during the day. Once you've done it a few times and realize there's no disruption, nobody even notices that you've done it, do that migration. But everything on the host-facing side is fixed. So on day one, when you create that volume and you assign it to that IO group, those are the paths that are presenting that volume. That never changes unless you do things like non-disruptive move between IO groups. So there, although we're changing the storage on the back end, and yes, we can non-disruptively change all the SVC nodes and upgrade that. It's the old triggers broom thing. Upgrade the cluster as many times as you want. It's still the same cluster, but it's now 5 generations of hardware later. However, you've not changed anything on this end. It's all still fixed there. When we do partition migration, we're doing both of those things. Now, this does raise a point. And one of the customers I was talking to yesterday said, so for years you told us multipathing doesn't work. You implemented NPIV to solve the problems of multipathing. And now you're telling us we need to use multipathing again. Well, it kind of works these days. It's moved on a lot. We've also found the various reasons why maybe we had a few problems with the way we were implementing things. A lot of it came from SVC has to know about everything before it can really start doing I/O. So we've got to go out and discover the back-end storage. We've got to go and discover all the partner nodes that we have, all the other clusters that are out there, all the hosts. Once we've got a view of the world, then we can start actually doing some I/O. Some operating systems don't like how long that takes us. So we bring the port online because we have to be able to discover all the things on the fabric. We start finding things, and the host's going, hello. And we're going, yeah, I'll get to you in a minute. I'm trying to find out what I'm attached to. Are you there? Yeah, I'll get to you in a minute. I'm just ignoring you just now. After a few seconds, it goes, oh, right, I'm going to kick the, are you there? Are you there? And it gets more and more aggressive, and eventually it goes, screw that, there's nobody there. And then we go, right, what were you saying? Oh, there's nobody there. Nobody's talking to us. So we discovered that some of those were the problems, and it was timings and those kind of things. That's what NPIV solved for us, really. That was where we can say we can bring the physical port online. We can go and do all our background work we need to do, discover everything, find all of that stuff. We haven't told the host yet that we're here. When we bring the virtual port on, now we can say, hey, we're here, we're ready, and then it logs in and starts seeing everything, and we respond in a timely manner. That was often why paths never recovered after things had gone away, or paths went away, never actually went back and tried to rediscover them again. So slightly different set of things, but in the sense of adding new paths in, we found that things have moved on a lot more, they're much better. Chris kind of pointed out earlier on that when we do this, essentially, it's kind of like the non-disruptive move between I/O groups in a way. We've got a set of paths here. These are your currently active paths. We clone the data, and once we've got all the data cloned, we've already cloned the logical stuff, but we bring it on and say, right, we're ready to do some I/O on this side. We can now tell whether the host is actually logged in to that port. With paths active, that's good. Has it started actually doing I/O on that port? Because we're presenting it as an active path that you can use. It's doing I/O on that port, great. Everything's great. We'll stop now because we don't want to delete the old one until you say, yeah, I'm happy to do it. There is obviously a continuum of how well hosts all do that. Certain ones, I think, Linux, VMware, a few of those today, brilliant. They can go all the way through that process. We don't have to get involved. And then we're ready to delete the old one. And we say, right, are you good? Is everything okay? We think everything's good. Other ones, we might get so far down the route and say, well, we think it's logged in, but we're not seeing any I/O on there. Let's stop and say, can you go and check? And maybe you need to do a rescan. Maybe you need to do those things. So it's much more, I don't want to say foolproof, but it's much more resilient than anything in the past. And it's going to stop. And the DMP that gets raised to tell you, these are the hosts that we think you might have problems. You might need to go and kick them, get them to rescan. So yes, we're going kind of to using the multipathing to get this to happen, but we've learned from all those lessons in the past. We've still got NPIV. We're still going to do all those things to make sure we're handling the paths correctly when we start up, but also making sure that we do that. Now this means, obviously this picture shows the SVC in it, but it means that's how we've been able to do this on Flash system as well. But same applies here. We're moving front end and back end. More capability, less restrictive than what we had with SVC. This is a bit of a busy chart, and I should really have split it up in several, but we talked a little bit about the scalability. Again, I'm just going to point at, I won't do it that side because the podium's in the way, and nobody can see me if I point at that side. Fixed cluster limits, okay? So I'm not sure if these numbers are correct or accurate. I think they are 16K volumes, 32K snapshots on a 2-node SV3, for example. Build an 8-node SV3 cluster, it's still 16K volumes, 32K snapshots. So it doesn't matter how many nodes are in the cluster, it's a cluster limit. Do a grid, we've now got 4 sets of 2 nodes. Each of those 2 nodes has 16 and 32, which means we now can have in total 64 and 128 in the case of having those 4. So it gives us that scalability beyond. Snapshots are really the important one. If we're all doing everything that Ian was talking about, we're doing our safeguarded copies, we're taking lots of snapshots on the system, you've got lots of volumes, we need to be able to keep as many of those as you were saying you want to keep for 7 days or however long you want to do. Yep.
Is there any difference? It's a long time since I used multi-IO groups in SSCs.
Yep.
But is there any of the logging mechanisms between the nodes and the pool configurations where you get just an iota more performance in separating them in 4 separate 2 nodes? I remember that doing PSA tests, that I could get more performance out of the 2 sets than one
on its own. So
there was a little bit of reserve logging mechanisms on the pool.
So it's probably not going to make a huge amount of difference other than the fact we're going to probably drive more concurrency in this mode, just because they're kind of individual things. There is some queuing algorithms and things in the back end. How many nodes do you have? How many? Yeah. So you might push a little bit more doing a grid, but that's probably a byproduct of we didn't quite get it right. We should have got the numbers different. Yeah. So that's on the kind of scalability side of things. Obviously, I've just picked on volumes and snapshots, but anything that was a cluster-wide limit now increases. Not that we ever put bugs in our code, but on the rare situation, and it's been hopefully quite a long time since these have happened, that something happens in cluster state. So those of you who have been around for a long time will know we have kind of separation of cluster code and kind of agent code, as it's called, running on the nodes. The cluster code is common. And essentially, it's running independently, but they're all running, doing the same thing at the same time. So when an event happens, they all kind of roll forward and commit a certain state forward. If there's something catastrophic happens in that, it can result in all nodes asserting at the same time. Hopefully you've never experienced that. It's not pleasant when it happens, and it does kind of recover and come back, but it's probably too late by that point. But that is a risk. I've said this phrase so many times. One day hardware will fail. One day software will work. So it's software. It's situation that there can be bugs in it. These are rare, but it could cause, if you've got 8 nodes, that's all 8 nodes going down. In this situation, not hopefully that it would happen, at least it's only going to just be 2 nodes that have gone away. It's not everything that's gone down. It's complicated to write that clustering code and to cater for n-way situations. So one of the reasons we've never really gone beyond 8 nodes, there's a couple of kind of, architecturally it should be possible to do it. We've tested it in the labs. We've done a few things over the years. Our excuse was always, we doubled the performance of the nodes, so you've now got 16 nodes of the old type and 8 nodes of the new one. And so we kept keeping the performance ticking over. But some people wanted more. It always comes up every so often. People wanted more. Doing that n-way code is complicated. Having to keep things and keep track of all of those nodes, it can be complicated. Therefore, having only 2-way things, it's much easier to code. It's much easier to test and exhaustively test all the scenarios there. And then, of course, the other thing is, if you've got an 8-node cluster and you're kicking off a software upgrade, it's all or nothing. So all 8 nodes are going to happen one after another. Odd ones, even ones, pause in the middle. It takes a long time, potentially, as well. I just had a customer in New Zealand, long-term SVC user. They were moving to cloud. They were being instructed to move to cloud, and that was a reason to do nothing. Oh, we're moving to cloud. Your XIVs are now 10 years old. Your V7000 Gen 1s went end of support a long time ago. Your 3700s went end of support a long time ago. And your DH8 nodes that you're currently on are on 781 code. So we found that pink is a better color than red. and it was very close to the pink there, that I put an age spreadsheet together of all their systems. Nobody looks when it's red. You say, yeah, sorry. Oh, what does a shocking pink mean? That means it's greater than 9 years old. And this is a hospital. Oh, do we need to do something? Oh, but we're moving to cloud. So they were moving to cloud at about 10 terabytes a month. Their organic growth was 15 terabytes a month. Assume your growth stops. That's going to take you 2045. You'll be off that XIV, by which point it'll be 35 years old. Oh, we better do something. So the reason for it is that eventually it goes to it's government, so it went through lots and lots of layers, and every time, oh, we're moving to cloud. Here, read this document. Oh, we need to do something. Eventually, we got them to agree. They refreshed the entire estate by this point. They had a DS8300 in there as well. Lots and lots of old stuff. They refreshed everything. They're paying less than they were on maintenance over the next 5 years. Everything all inclusive for 5 years. But then he had to go from 781 to get to SV3, 860. And I believe last weekend, the last hospital just got upgraded, and I didn't hear anything, so I'm assuming it all went okay. And so that's a lot of upgrades. Luckily, there were only 4 node clusters, but still, it takes a while. You did 4 back-to-back software upgrades in one change window, including the combined hardware and software upgrade on the last one. That was fun. But it all worked, and everything's now up there. But the key thing, software upgrades. You're only doing 2 nodes at a time. It means you can do things independently as well. You can pick off one. You could, if you're really, really nervous about things or you have problems, just move all the partitions off of that system, put them on another one temporarily, upgrade it with no workload on it, move them all back. So it's about gaining trust in that partition mobility, just as you had to gain the trust in doing the back-end virtualization migrations. Once you've got that trust, yep, I can do that, I can run it. Same thing now with partition migrations.
But again, a lot of the things that happen when you're doing a code upgrade is exactly the same with the multi-pathing drivers and stuff. And the partition mobility is using exactly the same, almost the same functionality. So basically, you're kind of testing a code upgrade by the mobility actually.
Sort of. I mean, again, depending on how you're doing it, and this is one of the things I hadn't actually thought about because it had been quite a while since I'd done a node replacement upgrade. The one slight side effect of doing a node swap is you do an RM node of the old one to take it out and then add the new one in, at which point all your NPIV ports disappear for that node.
I was more thinking of the upgrade example where you're upgrading and moving it across.
It's sort of similar, yeah. The workload's kind of switching over, but here you're keeping redundancy, you're keeping obviously the caching and all of those things by moving it across, but yeah. Yes, yeah, so at the point where a node goes away and comes back, the cluster code has to all sort itself out. There's slight pauses that happen. This would avoid those pauses if that causes you a problem for a particular application, very latency sensitive applications. Chris also pointed out to me that I should probably talk here about stretch clusters as well, and why doing this with PBHA is going to be more resilient, more redundant, keep the cache all the time, not relying on all the different layers, doing all the communications for passing things around as well. So lots of good reasons to think about moving into this world. The current stumbling block, and we'll talk about this in the roadmap as well, is how do I actually move into this if I have a more than 2 node SVC cluster today? So we can only do partition migration from a single IO group to a single IO group. If you have 2 IO groups today, you can't do it. We are working on putting something in that will allow us to pick the lowest ID IO group probably, get the volumes that you want application-wise, consolidate it onto that IO group, create a partition and do a migration of that partition, free everything off that IO group, remove it from the cluster, you reuse it if you want as a seed for the next IO group, and keep repeating over. So it is creating work. You could think of it as job security in a way. But we understand that we're on the cusp of a change, but we think this is the right thing to be doing for the future. It gives us the scalability. It gives us all of these advantages that we've been talking about in the long run, and it's going to help us to deliver more function quicker by having the grid type structures. With that said, at the moment, there is no plan to remove the clustering capability from SVC. So if you're in that and you're happy with it, you can stay with that. But this is the future direction. It's a bit like when we introduced NPIV in the first place, and then people go, I've had my SVC cluster running for a few years. I'll worry about NPIV later. I'll worry about it later. Yeah. And then you forget about it, and then you get to 8.6.0 and go, why can't I upgrade to 8.6.1? Oh, I haven't turned NPIV on. Oh, I guess it's later. I need to do it now. So
in your perspective, is it anything in the cluster mode that's better than the grid mode?
Talked about migration. Probably the end point here.
Okay.
Pools and MDisks. It fundamentally changes what you've been used to in the sense of I could have one giant pool that all 8 SVC nodes are talking to one common set of storage. I can have volumes here, volumes there. It's creating it slightly more siloed now because it's going to be a pool for that system within the grid. You've got the mobility to move things around, so you can move it from one pool to another. If your storage controller behind SVC has enough ports, you can obviously zone some of the ports to one cluster and some of the ports to another cluster. Then present MDisks from one controller to 2 I/O groups. It's obviously not giving you that common sharing of it, but it's allowing you to spread a controller across multiple systems. There's some caveats and things you need to be careful with there and make sure you don't reuse the same MDisk on 2 of them. You're a bit of a mess if you do that. It sounds like someone's done that. So you need to think very carefully, and what's the value of doing that? Is maybe you've got this giant storage system and you want to spread it, fair enough. Probably better to think more in siloed approaches to it. That was the only real thing. So to answer your question, Roger, that's the only real thing that I can think of is potentially different. That, and obviously the mobility is relying on multipathing working. Andy, Chris, Carlos, is there anything else that we lose or any other? Sorry? So standby nodes is an interesting one. So maybe you don't add the standby until you kind of want to have it there. I mean, a lot of people don't use the standby nodes. You hit that node unpen, pen kind of thing. If it's a bit of a planned maintenance thing, maybe you have a standby node that's kind of zone or capable to be used by any of those systems. You're probably not going to put a standby for every single, you can't afford to do that. So maybe having 1 or 2 standby nodes if you want and using them for maintenance type things rather than if a node dies, swap in.
But you could have them make 2 standby nodes, make them a separate cluster, and that's your migration cluster. So
yeah. Temporarily, and then if you need to do some planned maintenance, you could, if it's free, break them out and reuse them. Yeah. Sorry, Evelyn. Normally, I don't have a problem hearing you, but.
Hosts being panicky about it at first, I think is a thing we gotta overcome. So the fact that paths are appearing and changing.
Okay, yeah. So the general pathing of mobility of the partitions, yeah. But it's one of the reasons why things like PBHA we've been gradually kind of adding support, and we're having to go back and requalify all those hosts. Things like the persistent reservations took a bit longer than we expected, and those kind of things. But we understand we've got to get it right. We've got to get it on day one that everything's working. And I think the majority of commonly used OSs these days are supported there. think I probably, yeah, covered most of the things that are on there, and I think just the recap, pretty much on time, which is good. So yeah, main key thing, it's not showing up on there, is obviously being able to bring that non-IBM storage. If you do have things, if you're using non-IBM with SVC today, but you want to get some of those grid benefits, then you can use that to bring it in there. All right. Cool. Any other questions before I hand over to Andy for the next session? No. Cool. Thank you.
Can I steal your clicker? I'll borrow your clicker.
Yeah.
Thank you.
Do you have a real USB?
I have a real USB port because it's a real computer and everything. Oops, no, that's the network port. Okay. Everyone, my name's Andrew Martin. I'm the support architect for the Flash System Storewise Virtualize, Storewise, that's been a while, products. I think many of you know me, but if not, yeah, feel free to come and ask me questions later. And I do encourage stopping me to ask me questions, right? The goal here is for you to learn things, not for me to listen to myself. Okay, so the goal of this presentation is to talk to you about some of the stuff we've done in support. Some of it we've been doing for years, some of it you may have heard me rant about before. You know, you get opportunity to tell you some of the things we're doing behind the scenes that you might not know about that you can take some benefit of. Okay? So, support assistance. Has anyone got support assistance configured yet? You're all asleep. Hello, thank you. So, support assistance is one of our best named features, because this is the list of AKAs I came up with for it. We did a good job with this one. Basically, it's the technology we can use to remotely dial into your box. Okay, it's there for us to help you and to make your life a bit easier is the goal. But not that many people have necessarily got it configured. We are at a turning point now, which we'll come to in a minute. But yeah, we're getting there, and that's what it's there for. Those of you that said you have got it configured, are you using the XRSC proxy? No, good. You're using the XRSC proxy. I want to kill that thing. You don't need it anymore. Yeah, the goal is for those of you that aren't using it, give me a second. The goal of the XRSC proxy is to take the SSH and put it inside SSL. We do that on the Flash system itself now, so you shouldn't need that for much longer. Okay. So we can dial in and help you with the system, but it's under your control, right? Before we actually shipped this for the first time, we were talking to a big UK bank who were like, we want to have this thing and we want to have it always turned on so you can dial in whenever you want to. I don't recommend that, right? What we want you to do is we want you to have it configured but turned off, and then when you have a problem, turn it on to let us in, right? You have complete control. Okay, that's the first thing. You have complete control of this thing. We don't recommend you leave it turned on at all times, so you can decide when we can get in. It's all under the covers, simple SSH. So when you turn it on, we initiate an SSH connection back to IBM, and then that allows us to tunnel SSH back in. So it's all outbound. So no one's trying to remotely dial in, connect to your box from the internet. It's all an outbound connection. But then once it is, the nice thing is, being SSH, it's well-known security. Lots of people are fixing it for us all the time. It's really lightweight, really easy to use. Okay, and millions of people there are constantly making it better every year from a security perspective. The slight problem with it being based on SSH is that security people are allergic to SSH, and we found. So One of the things we use to help you if your security guy is allergic to SSH is we can take that SSH connection and put it inside a TLS connection to make it look like a web connection, and then they're fine. Just don't tell them. Okay. We used to do this using the thing called the XRSE proxy. Now the Flash system will do it natively, so it'll go out on port 443 using a TLS connection. It's still SSH inside that TLS connection, but it helps with the firewall police sometimes. Okay, but it's technically not HTTPS connection, but you don't care. Right? Sometimes I know things that I just want to tell you, but I don't care about. More importantly, that connection, we do not send any data through that connection apart from an interactive session. So either we're connecting to the GUI, in which case, obviously the GUI is transferring the stuff to us through that, or an SSH connection, in which case we're getting the bytes for an SSH. So we can look at things through there, but we don't transfer any files through that connection. We don't have many Blue Diamond customers outside of the US, but that's important for all of the normal regulatory reasons. Logs and files always go to ECU rep. We might use remote dial-in to connect and ask the system to send some logs to ECU rep for ourselves, but we won't ever pull the logs directly over that connection. Okay, so it's doing just the bare minimum to let us connect and manage the box. We log in with what's called a challenge response. Another way of thinking of it is a one-time password. Every time I log into your box, I need a different password. Okay, so it's not a shared password that anyone knows. It's one-time, one-use password. And in the audit log, if anyone's ever seen this, we can trace back from the action in the audit log to the IBMer that ran it. You can't, but we can. So we have got audit trail to exactly who did things. Okay. Any questions so far? No? Okay. If you're worried about who's using it, we put stuff in the GUI to show you it's there. If you're worried about whether we're using SSH ciphers, all the SSH security profiles are integrated as well. So all of this stuff just kind of works the way you expect it to. And when I connect, I'm connecting in basically as a super user. So I have the same privilege as a super user. Critically, I don't have any more privileges than super user does. So there are some other storage products, some IBM storage products, where when they dial in, they go in as the Linux root user. So they have full Linux privileges over everything. Yep.
You can't use any of the engineering, like seeing the tier levels on the storage.
There aren't any engineering levels in virtualize. It's all.
Yeah, but on the flash systems, you can connect them to the drive, right, and see the tiering status on the drive.
Yeah. Yes and no. So you could do those things as well, most of them.
Yeah, and use the command.
Yeah, there are a couple of commands we don't document. And for the FCMs, we've got a few ways of dialing directly into the drives, which again, there's another challenge response. So there are some things we can do with the FCMs that we can't do. But for the actual virtualize itself, yeah, we can't do anything you can't. Okay, so trying to give you an overview. What I'm trying to do with these bits is give you an overview of some of the key things in terms of security, right? So we've got auditability. It's using a well-known, well-trusted, well-investigated protocol for security. It's no special. We don't have anything magic here, right? We're just doing it as you. Most of us will connect through SSH directly and run CLI commands. Okay, so that's what it is. How does support use it? ... So we're currently going through a period of change, and that's because for a long time, most of our customers don't have this configured. Right? So if the support team, every time they get a new case, would just turn around and say, do you have SRA turned on? And the customer says no, that's just wasted 2 email round trips, if you like, in terms of getting the problem solved. So we have got in the bad habit of not even asking. If you do have it configured, right, and you're opening up a support case, feel free to remind us that it's there and we can use it. And the support team are more likely to pick it up then. Also, the support team are not yet comfortable with it, particularly because they don't use it very much. So we are currently going through a transition period where we're going to try and, for customers that have got 9500 with TAMs, specifically, we're going to start there, try and make it so the support team know that they should always try and use SRA for every case up at that top end of our support structure. And as we get the support team more familiar and more happy with it, will probably bring that down a bit. My instructions to the support team are, if you're working on a case and you think your life would be easier with remote dial-in, use it. But if the customer doesn't have a TAM, we won't necessarily respond to you saying you must use it, right? So there's a difference between when does the customer tell us to use it versus when do we choose to use it ourselves. Does that make sense?
One worry though, sometimes your support teams are a little bit, I would call it experimenting. I mean, could you just try these commands and see and say, oh, that's kind of intrusive, we wouldn't like that. How is that handled in that kind of support example?
Brilliant question. So the question for those who didn't hear it is, if you are experienced, right? So we have over here one of our most experienced customers, right? And you really know what's going on. How do you have control, right? So as part of this trial, what we're doing is we're saying that the TAMs will have to understand your change management process and your requirements on terms of approval, right? So we know there will be some customers that say, I don't care, just do it. Yeah, and there'll be other customers that say, you can only do it at 2 a.m. and I need 3 hours notice so I can do all the paperwork necessary before you do anything. And there'll be other customers that say, I want to review what you're doing before you do it, right? So that's one of the reasons that for the support trial, we're starting with the TAMs, because the TAM can build a relationship with a customer, understand their requirements from a change management and approval process, so that the support team don't have to ask every time, and we just know what the answer is. Okay, so that's one of the biggest problems we've got, is how do we integrate well with 5,000 different change management systems? Okay, is that a good answer? And if there's something specific you think we should do, let me know. Looking for ideas. Okay, so that's the thing. I would encourage you to go and set it up. It is relatively simple. What is my next slide? Nothing on this. It just requires SSL connection back to a few servers. So depending on whether you've got firewall holes open already for call home, it might be relatively easy. And it might be very helpful in the future when you're having a complicated problem. If we're not using this, we're always asking for try this and send a new snap, try this and send a new snap. If with this, hopefully a few more times we can just look at the stuff live. Okay, make sense? Have I convinced anyone to turn it on? Half a hand. Hey.
And the remote code support guys was checking remotely. It was going very well.
Yes, excellent.
And the reason why in some systems I installed this external proxy was that our 40 analyzer was not liking that traffic.
Yes.
It comes in, so that's why I put it in.
From 8.6, this traffic that comes out of Flash system is the same as the traffic that comes out of XRSC proxy, but before then it was different. Yeah. Okay, good.
Does this mean that you're not going to use the storage insights anymore for data?
So when it comes to pulling snaps, Storage Insights is going to do exactly the same thing I do if I log in this way. So in terms of just pulling snaps, we can dial in remotely and run the CLI command locally to pull snaps, or we can press the SI button. This is more about live looking at systems or possibly even making changes as well. We're more likely to use SI if you've got it to pull snaps because it's one fewer step. But equally, there are some customers out there that won't use Storage Insights but might let us do this. So it's just more ways of doing the same thing. Okay. All right. So the next thing on here was upgrades, and I thought to myself, what on earth am I going to spend talking about upgrades? And then I started writing slides and got like 20 of them. So brace yourself. Okay. So we get lots of questions recently. We've been using this whole long-term support versus non-long-term support. Non-long-term support, we're very good at naming things for quite some time now, but we still get a lot of questions not quite understanding things. So I thought I'd go through some terminology, right? So the first one is a long-term support release is where this third number here is a 0. That's a long-term support release. He says, crossing his fingers we don't change this tomorrow, but we probably won't. Yeah. A non-long-term support release has this third number as a 1 to 9, so not a 0. Okay? And then I had to go look this one up. IBM is in the room. How many of you knew what PTF stood for? Yeah, no, and we all use it. No one knows what it means. It's also a terrible name, right? A PTF is just a fix pack. It's a set of fixes without, in theory, without any new features or functions, just fixes. So that's when the last number changes. So if we go from 8702 to 8703, that's a PTF change. So the only thing that changes is the last one. These are our main kind of code releases. We also have a software upgrade test utility and drive bundles which have our drive firmware in them. So those are the things we put on Fix Central for the product itself. Nothing very surprising so far. But what are they? So a long-term support release has got new fixes and new features. So fix is good, features brilliant, but sometimes risky, right? But a long-term support release will receive PTF fixes for many months, if not years, well, many years actually, right? So we will keep, after we've released a long-term support release, we'll keep shipping PTFs on that for a long time in terms of security and defect fixes. Okay, that's what a long-term support is. It's not just drop the features and run, it's drop the features and then keep shipping fixes for those features. The non-long-term support release is not long-term support, right? So we drop a bunch of features, but in general, we won't ship fixes for that release. So if you want fixes for what's in that non-LTS release, those fixes will come in the next non-LTS release. So you'll have to pick up a new set of features as well as a new set of fixes. How well we do in terms of not shipping PTFs on the non-LTSs depends a lot on how often there are PCerts. Because we are required by IBM to ship security fixes within a certain timeline. So, you know, sometimes we're okay. We might get to 8. We might get to a .2, I think, on the 8.7.3 release. But yeah. So that's the goal of the non-long term. You get new features, but we won't ship fixes for them. You have to pick up new features to get that. But this here goes through exactly the same test phase, the non-LTS, as the LTS, right? So it's not that this is any lower quality than this. It's that we're just not going to keep shipping new fixes. So this one, we ship a bunch of features, and then over time we ship more and more fixes. So the number of people running it and the quality and the stability kind of has a nice upward trend. Whereas with the non-LTS releases, you're not going to have quite that same upward trend in terms of if I wait 6 months before I pick it up, 3,000 other people have already installed this and found the things and fixed them. You're not going to have quite the same experience. But you absolutely can, and I've got lots of very big banking customers running non-LTS releases in production, right? The goal for the difference was this thing allows our customers that just want fixes and stability to know where to go to. And this thing allows our customers who need brand new features and functions to get them really quickly, right? So if you need a feature, if you need or want a feature in a CD release, absolutely you should pick it up with confidence. If you don't need or want the features or functions in that, LTS is the default, right? So LTS is the default. Non-LTS is where you need a particular feature or function. Does that make any kind of sense? Yep. PTF, I then started filling in this chart with more stuff, right? Most of the stuff now is PTFs are just fixes. Our general goal is we'll ship a PTF every 3 months for the first year on a long-term support release, and then every 6 months after that. That goal is completely and utterly shot in the face by security vulnerabilities, which come along and say, you will ship this thing by this date, but that's our theoretical goal for PTFs on a long-term support, every 3 months for the first year, and then every 6 months after that. Yeah, it's all a bit up in the air though. And then upgrade test utility. So any questions on the first half before I go into the other bits?
Maybe it's a good idea to have some overview by releasing new features. What features will not work with other features?
Okay.
Now sometimes you have features that will not work if you have another feature running.
Yep.
Now you just have to go to some notes to find out if some features are applicable to your system because you're running other features.
So the question there was about how do you know whether if I upgrade here, I can't upgrade because this other thing is broken, or this I'm using some other feature and I can't have this with that, right? That's a good question, and it's a brilliant straight man question because it takes me straight into the software upgrade test utility, right? So you're in terms of documentation, we try very hard to make it so that most of the time everyone can upgrade if they want to, but there are some times that we either find a defect that means a defect, or we haven't got enough time to test it, which means that certain people can't upgrade to certain releases, and then we have to put upgrade blocks in. But yeah, we try, rather than making you read the release notes for that, we always try to use the upgrade test utility so that we read the release notes for you. Okay, so whilst it is annoying that sometimes you can't upgrade, we do at least try and make sure that we're helping you to get the right decision. Okay. The software upgrade test utility is a tiny little package that contains a list of known upgrade problems. So for example, if tomorrow I decided that a system running PBHA with exactly 3,210 volumes, if they upgrade to 8730, they will hit a defect, right? I can put out a new upgrade test utility tomorrow to stop anyone with, let's say, more than 3,000 volumes from upgrading. Okay, so that way, our goal in support is to say defects are going to exist. Customers are going to hit defects. We want to get the number of occurrences of each defect as close as we can to 1, right? So once one person's hit it, we want to make sure no one else hits it. This software upgrade test utility is our key, a key part of that strategy, because I can spin that really quickly and protect anyone else that's exposed from going and upgrading, whilst not preventing people that aren't exposed. Yeah. So this is a really tiny bit of software. It's really small. It's really quick to download and install. Always, 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 always use the latest version. Because if you use a version from 3 months ago and you're exposed to a particular issue we found last week, you're not protected. Okay.
It makes you use the latest one.
It doesn't quite make you use the latest one. If the one you've downloaded is more than, I think, 3 months old, it will refuse to run. But if it's a week old, it won't. It might be 1 month. Anyway, it's measured in months, not days. Yeah, so we've put some protection in there to say, don't let people download it and keep using it for the next 6 years. But it's still, it doesn't mean that there isn't a new version. And you laugh. So yeah, this is a key. This is the single most valuable tool we have to protect you and to help us meet our goals to be an enterprise class product. It helps us keep the number of occurrences of any defect that happens to get into the field to 1. And it's very, very successful. It's very, very powerful, and it's very, very simple. So if you take one thing away from today, make sure you always use the latest. Okay.
That's all right for if you've got a really captain environment. If you're on Insights, why don't you integrate that with Insights such that you're always using the latest?
So the question was, why don't we integrate with Insights? Because the upgrade test utility can access things that Insights can't. Because the upgrade test utility can go and poke around in the file system and actually do some really clever things that you can't access through the CLI. So we need to install it every time. We are looking at whether we could do ways of automatically upgrading it, for example, using some of the automatic upgrading things. So integrating with Insights isn't the right answer because there are lots of things that Insights can't know about. But automatically upgrading, which actually has nothing to do with Insights, is something we are looking at. Yeah.
Practical question.
Yep.
I was running 8721.
Yep.
And I have iFix 3, and I recommended this to combine the iFix 4 also.
Okay.
Then I checked that there is a 872.2 and 873.
Yep.
At the same time.
I'm keeping most of these numbers in my head.
Yeah. But all those at the same time, same week released. So 872.2 or 873.
Yep.
So I was a little bit troubled to understand what was happening
Okay.
there, because I need to also understand that are those iFixes already there to kind of read all the release notes and
Yep.
list those. So why this 2.2 and 3?
So the question was, we did lots of releases on the same day pretty much, and you were going to it, and there's also an iFix question in there. So let's address the first one. When you see us putting out multiple PTFs on the same day, it is always because we are running this close to hitting a deadline on a PCert. So the day after you saw those 2 PTFs come out, we put out 7 security vulnerability flashes, and one of them was a 9 and had a deadline of the day after. We got there. In your particular case, we put out 872.2 so that we could release the flashes, because we didn't think we could get 873.0 out in time. It was just a mess, right? So when you see us collapse lots of PTFs like that together, it's almost always because we're required to put out PCerts for everyone, and we've got to hit a deadline. And probably that deadline is the day after we've done the thing you've seen. I know it's frustrating for you. That's normally the reason why we put them out in batches. In terms of, this was a bit special. The 8722, we only released 8722 because we didn't think we could get 8730 out for a different reason. And then we got it out anyway, so it was a mess. But, so that's the why did I see lots of these things at the same time? Because for us to put the security vulnerability out, we have to make sure that every single one of you can install the fix. And only then can we complete our work and put the security vulnerability out. And we've got to do all of that by a certain deadline. So that means we've got to get I think at the minute, we've got to get the fix out in 8.6, 8.7, 8.8, and then the latest CD as well. Right.
Because in 8.7.2.2 there was that much of fixes, and,
yeah.
and 8.7.3 there was that much.
Yes. Hopefully there's a lot of overlap between those fixes, but yeah.
There was, but
no, we didn't release. 8722 was an extra special weird release because it was only ever supposed to go to manufacturing for the C200. And then we were like, we're not going to hit the security deadline. We've got 8722. Could we just ship that? And that would make us meet the deadline. We're like, yeah, woo. Security deadlines kill us, okay? It is difficult, I know. And iFixes make it extra hard because you've got to come and ask us if your iFix is included. But, okay, so that was, I think I've gone off on a bit of a tangent there. Was that helpful and useful?
Yeah.
Hopefully it was interesting, at least to some of the rest of you. But yeah, we do that. So moving on. We talked about where you get fixes. Oh, upgrades. So the goal is, if you're on a long-term support release, you can upgrade to the N+1 or N+2 long-term support release in a single step. Any more than that, we're just going to block. Right, so that means if you did an upgrade every 2 years, you're very naughty, but you could probably still do it in one step. Whereas for the non-LTS releases, you can upgrade within this 8.7, or you can upgrade to the next LTS, but you can't go quite as far in a single hop. And this is all about us keeping our testing matrix under control.
I would say that 870 is special.
There's lots of specials. This is the vision until a developer like Chris comes along and goes, Andy, it's too hard to do that. Do we have to? And then we go, yeah, all right then. So this is the vision, and the reality doesn't always meet the vision. Just like as you pointed out, our vision of never shipping PTFs on CD releases doesn't happen. But there we go. Okay. I can't remember. Why is 870 special today? I can't remember. Okay, so if you want to get to the release after 870 and you're currently on a release below 870, you will have to go through 870 for a technical reason that I've forgotten and doesn't really matter. Yeah. Okay. Still with me. So Then you've got to pick which thing you're upgrading to. I'm running a bit long and I'm bored of myself. So I thought we'd do a worked example. This right now is the set of things you could choose from in the 8.7 stream in terms of what do I upgrade to, yeah? It's doing my head in that most of these are anagrams of each other. It's doing my head in. So what do we want you to do here? So the first tip is, in general, never upgrade to anything but the latest PTF. Okay? The whole reason other people have found bugs, we've shipped them, you should have the fixes, not the bugs. Right? That's tip number 1 for Andrew. So that gets rid of half of those. Tip number 2, apart from under exceptional circumstances, if you're looking to use a CD release, always use the latest CD release. Okay? So now we're down to only 2 options, which are anagrams of each other. 8730 and 8703. And final tip is, once the next long-term support release comes out, and we couldn't possibly tell you that it's going to be called 910 because that's definitely against the rules, at that point, don't use the CD releases that came before it. Just go to the next LTS. So those are some tips to help you take that mass of 10 options and pick which one you should go for. And then a lot of the other tips in there are about how long has that thing been out, how long has it been running for, what features and functions you need, things like that. Okay?
You mean day one?
Sorry?
You mean day one as it's released? I have some people a little bit skeptical.
Yeah, so you might want to leave, you might add some time delays to this as well, but just in general, if you assume that enough time has passed, this is kind of a guide. We don't ever really want you to pick up, but what we don't want you to do is wait for 8700 to have been out for 6 months and then install 8700 when we just shipped 8703 with all the fixes. The reason you waited 6 months was so other people could find the bugs for you. So surely you want to install the fixes, not the buggy version, right? Of course, none of our code is buggy, but hopefully that helps understand. So I am at time, and I'm not quite all the way through. There are some web pages in here for where some of our upgrade recommendations are and some details about what can upgrade to where. The main thing I want to give you on this one is, for the software upgrade test utility, run it a month before, run it a week before, run it a day before, and then run it a minute before, okay? You don't want to find out when your change window is starting that your upgrade isn't supported, okay? So in reality, you don't have to do exactly that strategy, but the point is, as you're planning for an upgrade, run the upgrade test utility multiple times running towards the maintenance window, just to make sure that everything is still supported and we haven't released a new block for your particular upgrade, okay? If you've been qualifying 8702 and then 8703 comes out, even if you've started rolling out 8702 across your estate, I really would recommend you consider for the rest of your systems in your estate going to 8703 instead. I know for some people that's an absolute no-no, and every box on the estate has to have exactly the same version number. But really and truly, again, with that thing, right, you've been delaying to get other people find the bugs and let us fix them first. If you're able to talk your bosses into saying, we can ignore the last number in terms of same version, your lives will be better and so will mine, okay? So that's just one of those other things. I had some more things on here. The main one I'm going to say is, please configure call home. We can do so much to help protect you. We do so much work inside IBM these days, monitoring all the systems worldwide, looking for issues and proactively warning you about them. If you haven't got call home turned on, please turn it on. And if you do turn it on, go and find the advisor tab in Storage Insights and look there, right? Because we've written a whole bunch of automation inside IBM to analyze your configuration and tell you where we think something may not be optimal. And here's, including when I think that things are going to run out of space. And they're all buried in this advisor tab, which is sometimes a bit hard to find in Storage Insights. Barry said earlier, you can't have any presentation without mentioning AI. Well, this advisor tab is AI, it's Andrew intelligence, right? Because genuinely, when we see issues, I'm one of the first people to go and write alerts and push out things. We have a drive firmware package we released yesterday, where the drive, when it reaches an exact number of IOs since boot, that drive will panic and reboot itself. Wonderful bug. So if you happen to have one of those drives in your system, there would be a big error box on your Storage Insights Advisor saying, you're exposed to this flash, go and read it. Sorry?
Which kind of drive?
It's a nearline SAS drive. I can't remember the details. It's not a flash drive. So yeah, the basic thing here is, please do call home, let us help you. Please do Storage Insights, look at the Advisor tab, and hopefully that was interesting. And if you've got any questions, I'm here all 2 days. Please come and find me. I'm happy to talk, as you can tell. Right?
Thank you.
And thank you very much for your time. It's now a break, so you get to go and eat something or drink something.